when we talk about the history of human flight,
Mm,
the narrative is always so straightforward, isn't it? It's very linear.
very recent.
Very recent, exactly. It always starts with that familiar story, the Wright brothers at Kitty Hawk in 1903.
Right. Or maybe you'll rewind a little bit to like Leonardo da Vinci's sketches or their first hot air balloons.
Sure. But the whole story of humans conquering the air is supposedly a modern one.
But our sources today suggest that this accepted history, well, it's incomplete at best. And it might be wildly inaccurate.
I think that's putting it mildly.
We are diving into a world where ancient texts, written thousands of years ago, detail the mechanics, the materials, and the operation of these incredibly sophisticated, self-moving aerial cars.
And not just cars. We're talking about machines that were apparently capable not just of flight, but of sustained space travel.
Exactly.
And that's our deep dive today. We are taking a massive intellectual leap way back in time to unpack the source material surrounding Vimanas, these legendary flying machines of ancient Indian lore.
You find them documented everywhere, across the Vedas, the Ramayana, the Mahabharata.
And our mission today is really to go beyond just the myth. We want to use these ancient technical descriptions. I'm talking about the specific alloys they detailed, the really peculiar fuel sources they recommended.
And the complex aerodynamic designs they laid out.
Yes, and measure all of that against what we know from modern aerospace engineering.
We're going to be digging deep into documents like the Vaimanika Shastra and looking at some modern comparative analysis.
We're looking for those surprising, specific nuggets of technical information that just feel completely out of time, anachronistic.
And the connections we find. I mean, especially when we start talking about a sophisticated ancient Mercury propulsion system.
Right.
It's really going to demand that you reconsider what you think you know about ancient history.
So to set the stage, we really have to understand the scale of what these texts are describing. These were not, just chariots being pulled by mythical horses through the sky.
No, not at all. The Vedas describe Vaimanas as being capable of flying from one place to another, one country to another, and one planet to another.
And that last part, one planet to another, that is the literal definition of a spacecraft.
It is. There's no other way to interpret it.
And one of the most compelling concepts here, and I'd almost say it's philosophical, is this idea of the kamagam yanam,
Which translates roughly to...
a thought-powered aircraft.
Right. The machine moves based on the intention, the will, or just the thought of the person operating it.
It's this remarkable intersection of, engineering and consciousness.
I think so. The idea that a vehicle could be controlled by pure mental input. It's not just some fantasy element they threw into the epics. It represents an ancient articulation of a technology that, frankly, we're actively pursuing today.
Oh, absolutely. I mean, if you connect this to the bigger picture, it resonates so profoundly with contemporary research.
You're talking about neural engineering?
Neural engineering, biomedical engineering, everything focused on developing advanced brain-computer interface systems.
BCI.
Right, where researchers are literally mapping neurological signals to output commands.
And the goal is literal thought-controlled mechanics. So when you look at it that way, the Yanam stops sounding like a magical device.
And starts looking like the ultimate hands-free user interface.
Exactly, a concept thousands of years ahead of its time.
So to really start this technical journey, we should probably ground ourselves in the definition of the technology itself. The ancient acharyas, the teachers, they gave a surprisingly clear, really functional definition of a Vimana.
And what was that?
They stated, that which can speed on earth, on water, through air, by its own power, like a bird, is a Vimana.
What really stands out to me in that definition is, well, it's the autonomy and the multi-domain capability.
Yeah.
It's not just an airplane. It's an autonomous, self-propelled vehicle, and it operates across land, sea, and air.
It's an all-terrain vehicle in the truest sense of the word, a convertible transport system.
And the sources get even more specific. They categorize these machines based on the era, or yuga, in which they were supposedly used.
Which is fascinating in itself because it implies that the technology and its underlying principles actually changed over time.
Almost like different generations of product lines.
That's a great way to put it. It sounds like a detailed historical product catalog based on the power source, which is just incredibly unique for an ancient text.
So how did these energy sources evolve, according to the texts?
Okay, so they fall into three primary historical categories. The oldest ones belong to the Trita Yuga, which is an era often associated with, let's say, greater spiritual power.
Right.
These are the Mantrika Vimanas. The sources say there were 25 varieties of these.
And the most famous example would be?
The Pushpaka Vimana, which features really prominently in the Ramayana.
Okay, but if this is supposed to be a technical manual, why would they categorize some of these craft as being mantra-powered?
Right.
Does that just mean they were purely mystical, or is there some forgotten science behind that word?
And that is the absolute critical question, isn't it? When we hear the word mantra, our modern minds tend to just immediately dismiss it as magic.
Sure, chanting magic words.
But if you look at the definition, mantras are sonic vibrations. They are specific combinations of sound that create resonance and energy.
So, not magic words, but sonic engines.
It's highly plausible that mantra-powered means these Vimanas were propelled by acoustic energy or some kind of focused vibrational resonance. It could be they were using principles of sound and energy conversion that are just completely lost to us now, but are still fundamentally scientific.
That completely shifts the perspective. Okay, so what came next? After the Mantrika types in the Dwapara Yuga.
Following those, we have the Tantrika Vimanas, and there were apparently 56 varieties of these.
56.
And the text describes their power source as being derived from incorporating the junction power of sky and earth.
Okay, that description is incredibly opaque. What on earth did the ancient authors mean by junction power?
I know it sounds vague, but we have to pause and really think about it. We can't just label it as metaphorical and move on.
Fair enough.
Ancient knowledge often used metaphor to describe forces that we would now just call physics. So junction power could potentially refer to harnessing static electricity generated between the atmosphere and the ground.
Or, what, maybe drawing power from the Earth's magnetic poles, some kind of geophysical energy.
It could be. It might also refer to a sophisticated conversion of solar energy as it interacts with the atmosphere, the Vimana itself acting like a giant flying energy collector.
So maybe a form of atmospheric energy harvesting instead of just pulling power from a generator on board.
I think that's a reasonable interpretation.
Okay. And finally, what about the most recent type, the ones most relevant to modern engineering?
Those would be the Kritaka Vimanas. They belong to our current era, the Kali Yuga. The sources detail 25 varieties of these, and that includes the famous Rukma Vimana.
And how are they defined?
These are defined as artificial engine-powered machines. They require highly complex construction using specialized metallurgy and mechanics.
So these are the truly mechanical aircraft. They rely on physical power engines to fly.
Exactly. They are the most recognizable to us from an engineering perspective.
All right, so now let's widen the lens a bit. Was this ambition for high-altitude flight something that was isolated to ancient India?
That's a really important question. Were different ancient cultures all observing similar phenomena? Maybe suggesting a global common source of knowledge?
Or did they all just independently come to the same conclusions about the nature of the cosmos?
Well, we find some really striking accounts globally that speak to a profound, I'd even say scientific understanding of altitude and the Earth's shape.
Where should we look first?
Let's take the 4,700-year-old Babylonian text, the Epic of Ethna. It describes the flight of a man named Ethna with an eagle high into the sky.
And it details a gradual, systematic shift in his perspective as he goes up.
Yes, and the detailed progression of the view is what makes it feel so authentic. The text says that after ascending for just 1 hour, Ethna looks down and notes that the Earth now looks like a hill.
And the sea?
The sea looks like a well. That's a massive scale shift in just 60 minutes.
It accelerates from there, though.
It does. After the second hour of ascent, the Earth is explicitly compared to a grinding stone and the sea to a pot.
But here's where it gets really incredible. After the third hour,
the Earth has shrunk to just a speck of dust, and the sea is completely invisible.
the comparison of the distant Earth to a grinding stone and the fact that the sea completely disappears, that strongly suggests the authors knew about the planet's curvature.
It does. They were describing a view from deep space that only becomes apparent when you escape the near atmosphere. For a text written 4,700 years ago, that kind of knowledge is, well, it's revolutionary.
And we see a similar level of environmental detail in the Book of Enoch, don't we?
We do. That text recounts a trip to space where the traveler experiences these violent environmental extremes. It mentions specific temperature swings.
It says, and it was hot as fire and cold as ice.
Right. And it also notes coming into a region of great darkness.
Which is a perfect parallel to orbital mechanics. The sources explain that when the traveler was on the sunny side of the journey, they felt that intense, unfiltered solar heat.
But when they moved to the shady side, The lack of atmosphere resulted in the intense, absolute cold of space.
The Great Darkness.
Exactly. These aren't just poetic descriptions of flying high. They read like sophisticated, almost scientific accounts of environmental hazards that are very specific to space travel.
And if we look for actual physical attempts, even very rudimentary ones, the history of this ambition for flight confirms it was a global thing.
You have to look at China. They're credited with inventing the two-stage rocket, named the Fire Dragon, all the way back in the 11th century AD.
Which proves the basic principles of propulsion were being conceptualized and used very, very early on.
And then there's that great anecdote of one who, around 1500 AD...
Oh, this is the one with the chair.
The chair, yes. It just provides that essential touch of human ambition and, well, occasional failure. This inventor tried to launch himself into space by sitting on a chair that he had powered with 47 skyrockets.
And 2 large kites, for good measure.
And 2 large kites.
Yeah.
The attempt, as you can imagine, resulted in a mighty blast of thick black smoke and one who was never seen again.
It's a tragicomic legend, but it captures the spirit of the time, the drive for mechanized vertical flight. Even if it was just based on gunpowder impulse, it was a relentless global ambition long before the industrial age.
Absolute.
Okay, now let's turn our attention to the central source document for a lot of this, the Vaimanika Shastra, or Science of Aeronautics.
This text is attributed to the great sage Maharishi Bharadwaja, and it was apparently derived from his even larger, more comprehensive work, the Yantra Sarvasva.
Which means all about machines.
Exactly. And the fact that this document exists as part of a larger work dedicated to all mechanical devices lends it significant credibility as a technical text, not just a spiritual one.
And it finally entered the modern public consciousness when it was translated and published by G.R. Josier in 1973.
Right.
The scope of it is just incredible. It details the construction and operational use of various aeroplanes across 8 comprehensive chapters, 100 distinct topics, and 500 instructional sutras.
It really does read like a detailed engineering manual designed for construction and for training.
And that training, according to the sources, was incredibly rigorous.
Oh, yeah. According to the ancient commentator Siddhanatha, to be considered a competent pilot of a Vimana, you needed to master 32 specific rahasyas, or secrets.
And this wasn't just a matter of, operating the controls.
No, not at all. It required mastery over tactical defense, stealth, and some pretty exotic weapon systems.
This is a huge leap from basic piloting. Let's unpack some of these 32 secrets, because they sound exactly like the classified capabilities of a modern fighter jet.
Let's start with stealth and deception. The text describes the ability to become visible and invisible, which was known as Gouda.
And we're not talking about magical disappearance here. This is some kind of visual shielding.
That's the idea. The pilot also needed the ability to instantly change the craft's physical appearance, to look either frightening or pleasing.
Which sounds like some kind of holographic projection.
It does, or to become completely enveloped in darkness using something called the Tamo Yantra, which suggests a mechanism for generating thick, black visual obscuration.
Or maybe a heat-absorbing stealth coating.
A very real possibility.
Okay, what about offensive capabilities? The technology they describe is equally advanced. Tell us about this thunderous din weapon.
That would be Mahashabda Vimohana. It required the pilot to concentrate the Air Force within 7 specific tubes of the Vimana.
To what end?
To produce a tremendous crescendo of thunderous din. And this noise was calculated to be powerful enough to stun enemy pilots and troops on the ground.
Rendering them insensible and disoriented.
It's an acoustic weapon, essentially a sonic stun gun.
Then there is Karshana, which is the magnetic pull technique. This sounds even more abstract.
Karshana is extremely interesting because it introduces the concept of directed energy. It required the activation of Jwalani Shakti.
Which translates roughly as flaming power or burning energy.
Right. This power was set aflame in a specific pipe while switching the wheels to a measured heat of 87 degrees. The resulting magnetic pull was then used to destroy enemy planes.
How? By pulling them in?
By drawing them into the path of this burning energy envelope.
Wow. So if we try to interpret Jwalani Shakti through a scientific lens, what are we talking about?
We're talking about creating a focused magnetic or maybe an electrical field that could disrupt the mechanics of another machine.
And the specificity of the instructions using measured heat degrees, 87 degrees, 272, 307, it suggests these were highly technical, controlled processes.
These are not just poetic descriptions of a battle, these are operational instructions.
The Vaimanika Shastra also prepared pilots for specific aerial combat dangers. One of the most telling secrets is Langana.
The ability to leap into safety.
Exactly. And it specifically addresses a hazard of high-altitude flight. When crossing dangerous airstreams, the Vimana faces the Badaba glow of the sun and can catch fire.
Wait, catching fire due to the sun's glow? What is the technical implication there?
It seems to indicate an awareness of atmospheric and near-space hazards that modern pilots face every day.
You mean like atmospheric friction?
The sun's glow probably refers to the extreme heat generated not just by direct solar radiation, but by atmospheric friction at incredibly high speeds.
Combined with the radiation hazards like solar flares or cosmic rays that you find at high altitudes.
Exactly. And the solution they proposed, to conjoin electric and air forces and center them in the Vaimanas life center.
That's essentially an ancient instruction for balancing electrical forces and aerodynamic stress to stabilize the vehicle.
It's to prevent catastrophic structural failure or atmospheric ignition.
That level of required technical defense means the aircraft structure itself must have been incredibly durable.
Which brings us to material science. What were these high-stressed, high-temperature machines actually made of?
This is where we hit another gold mine of specificity. The primary metals for construction were categorized as ushmapa,
Which means
heat-absorbing or heat-resisting metals. These properties were paramount for survival during high-speed, high-altitude maneuvers.
And the texts even name the root metals used to make the alloys.
Yes, 3 root metals, soma, samdala, and morthwika, that are mixed to form 16 different specialty alloys.
And the most important of these, the king of them all, is Rajaloha.
The king of metals. It's specified as the most suitable alloy for the advanced mechanical Kritaka Vimanas, like the Shakuna.
And the manual gives a recipe for it that's so specific it reads like a laboratory procedure.
It really does. Rajaloha is formed by mixing 3 parts soma, 8 parts andala, and 2 parts mardwika, and then you add borax.
And the heating process is critical.
It has to be heated thoroughly to exactly 272 degrees in a smelter, melted, and then churned into the alloy.
And the resulting material was supposedly goldish in color, light, hard, and had a high tensile strength.
And the detailed list of other components used in various Vimana materials is this bizarre mixture of metallurgy and, well, botany.
Yeah, you find ammonium chloride, benzoin, lead, iron, silver, mercury.
But then you get these crucial additions from the natural world used for very specific engineering purposes.
Like the Ladra plant.
The text mandates the inclusion of the Ladra plant, which was used specifically to prevent radiation.
And mica was incorporated to reduce heat flux, stabilizing the temperature inside the aircraft.
Right, so the ultimate function of Rajaloha was explicitly defined as protecting the body of the craft from external heat flux and high-temperature environments.
So if we compare Rajaloha's purpose protecting the internal structure from external heat to modern materials science, particularly for space travel,
the parallel is inescapable. We are talking about thermal management in extreme environments.
the source material itself draws the comparison to NASA's modern space shuttle heat shield tiles.
Which were often composed of ceramic matrix composites. These tiles are meticulously designed not just to resist heat, but to manage and dissipate heat flux during the intense kinetic energy of atmospheric reentry.
And the ancient authors seem to have isolated and prioritized the exact same material property, high temperature absorption and resistance.
And the use of mica, specifically to reduce heat flux, is a stunning technical detail. It shows a clear understanding of thermal insulation and material conductivity.
The fact that they were apparently achieving this by blending metals with plant matter and specific minerals is what makes the whole concept so compelling. It's so much deeper than just simple fiction.
Right.
All right, let's move from materials to motivation, propulsion.
Okay.
We now turn to the most controversial fuel source often described in these ancient texts, Mercury.
Called Padmarasam in Sanskrit.
It sounds so counterintuitive. Why would a civilization focused on high-speed flight use a toxic, heavy liquid metal as a fuel source?
And yet, texts like the Samarangana Sutratara describe a mercury vortex engine.
When the Vaimanika Shastra was first brought to light, critics just universally dismissed it, right? They said the design couldn't fly, and mercury certainly couldn't be used as fuel for combustion.
But that criticism makes a huge assumption that it was chemical combustion.
Right.
Subsequent modern analysis has suggested that mercury can indeed be used as a propellant, just not through a chemical reaction.
How, then?
Through electric propulsion, or by applying intense magnetic fields. Mercury's critical advantage here is its extremely high density and atomic weight.
So when you ionize it,
Exactly. When ionized, these heavier atoms provide much more thrust per unit of input power compared to lighter elements. That makes them excellent candidates for low-thrust, high-efficiency systems, like an ion engine.
this analysis provides a scientific context for the ancient claim, and then there's that incredible, though very contested anecdote of Shivkarma-Puji Talpade.
Yes. Talpade was a Sanskrit scholar in Mumbai, and he took the teachings of Bharadwaja very seriously. He attempted to prove them in the 19th century.
So in 1895, he constructed an unmanned aircraft named the Marutsaka.
Which means friend of the wind.
And the reports around this event are just explosive. The sources claim that Talpade's vehicle, which was powered by a Mercury engine based on these ancient schematics, successfully flew to an altitude of 1,500 feet before it crashed.
Which, if true, would place a functioning engine-powered aircraft almost a decade before the Wright brothers.
Now, mainstream historians contest this heavily.
They do. But the crucial takeaway for our deep dive is the engine type. The Marutsaka was reportedly the first model to utilize what we would call an ion Mercury vortex engine.
And this leads us to this bizarre historical parallel in the U.S. space program. Decades after Talpade's alleged flight, modern engineers independently turned to Mercury for propulsion.
Driven by the exact same technical needs, efficiency, and density that the ancient texts might have implied.
So you're talking about Robert H. Goddard, who did the first experiments on ion thrusters.
And then Harold Kaufman, who successfully built the Mercury ion thruster in 1959 at NASA's Glenn Research Center.
And this technology wasn't just theoretical, it was successfully deployed.
It was. On the CERT-1 mission in 1964, that's the Space Electric Rocket Test 1.
And this mission successfully operated a Mercury and cesium-based ion thruster for 31 minutes during a suborbital flight.
This is clear, documented evidence of NASA using Mercury as a propellant. It's a direct parallel to the ancient Padmarasam fuel.
So why did they choose Mercury and cesium?
The choice was pragmatic. Mercury is liquid at room temperature, cesium is solid. That made storage relatively simple. But both required high heat to vaporize them into a gas state before they could be electrically charged and accelerated out of the thruster nozzles. It was complex, but incredibly efficient in terms of propellant mass.
The parallel is astounding, but it does end with a reminder that technological advancement has to include safety. Why did NASA pivot away from this ancient yet seemingly viable propellant?
It came down to health and environmental hazards. Cesium is radioactive, and mercury is a potent neurotoxin.
So the risk of gas leaks during construction, testing, or cleanup
Posed serious, unacceptable health risks to the personnel. So in the 1970s, NASA made a dramatic shift. They abandoned mercury in favor of xenon.
which is inert.
Inert, simpler to handle, and it achieved similar operational results without the toxicity. The ancient technology, whether it was functional or not, was developed long before neurological safety was even a concept.
Okay, let's move from the engine to the structure. We have source material that compares the Rukma Vimana directly to the modern SpaceX Dragon capsule.
That feels like a colossal structural kinship to claim.
It does, but the comparison is based on the functional architecture and the aerodynamic viability.
Okay, so describe the Rukma Vimana.
It's described as having a main body shaped like a cylindrical cone or a dome. And crucially, it was designed for vertical takeoff and landing. VTOL. It didn't need a runway.
And how was this lift achieved?
Using 4 vertical ducts or fans that converted solar energy via something called a sun crystal into electromechanical energy.
What about performance?
It was claimed to reach speeds of 725 miles per hour and carry 3 passengers.
Now, a lot of the criticism was that this ancient conical structure was inherently non-aerodynamic for flight within the atmosphere.
Right, but the sources we're looking at addressed that. They demonstrated that the design is, in fact, structurally and aerodynamically viable. It complies with Newton's laws of motion when you factor in the VTOL and the energy conversion system.
And that structural similarity is reinforced by the modern comparison.
Exactly. The NASA SpaceX Dragon spacecraft shares this exact aerodynamic structure. It's a conical capsule designed for a vertical landing, carries up to 7 passengers, and it's highly modular.
It's divided into a nose cone, a pressure section for the crew, a service section, and a trunk.
The Rukma Vimana, in its basic conical shape and capacity, shows this undeniable kinship with a highly successful modern space capsule design.
It's a striking comparison.
And we should probably take a moment to briefly mention the capabilities of some of the other designs, just to show the breadth of their aeronautical imagination.
Absolutely. We should talk about the Tripura Vimana.
This was a huge specialized craft.
Huge, operated by solar rays, and it had an incredibly modular design. It was divisible into 3 separate parts.
Specifically designed to function for land, sea, and air travel.
It was an ancient amphibious modular transport system. It could reconfigure itself based on the environment it was in.
That's a fascinating level of modularity. And the Rukma Vimana.
The Rukma Vimana was considered the pinnacle. It was explicitly defined as a cross between a plane and a rocket.
And described as having the most complex and sophisticated aeronautical design among all the Vimanas cataloged in the Vaimanika Shastra.
It truly represents the zenith of their theoretical flight technology.
Okay, so if we connect all of this technical material back to the broader context of the ancient epics, we see that these highly advanced machines, well, they weren't reserved for scientific study or peaceful travel.
No. Overwhelmingly, they were tools of mass warfare.
The epics contain these detailed, frankly frightening accounts of massive aerial conflicts that suggest this advanced technology was regularly weaponized, used, and abused.
And the most famous example is the war recounted in the Mahabharata. It centers around the destruction of Krishna's capital city, Dwaraka.
By the Asura king Salva and his aerial fortress, the Sabhapura.
And the Sabhapura sounds less like an aircraft and more like a tactical flying city. It was a technological marvel used for brutal attacks, raining hails and missiles down on the people of Dwaraka.
Its most lethal tactical feature was its maneuverability and its stealth.
The text describes it as very mysterious. Sometimes it was fully visible, and sometimes it was invisible.
It flew like a whirling firebrand.
And warriors on the ground couldn't lock onto it because it was never stationary. It exhibited these high-speed, evasive patterns that just defied ancient tracking methods.
Krishna eventually went airborne in his own Vimana to counter Salva, and the conflict described reads like a modern air battle.
Oh, absolutely. Salva's forces were using rockets, missiles, spears, spikes, battle axes, 3-bladed javelins, and flamethrowers.
But Krishna's counterattack involved weapons that sound incredibly sophisticated. They suggest guidance systems.
Tell us about that.
Well, when the Salvapura became invisible, Salva's troops, the Danivas, they began screeching loudly to taunt Krishna.
And Krishna then deployed a unique weapon, an arrow that killed by seeking out sound.
Wait, killed by seeking out sound?
Yeah.
That is suspiciously similar to an acoustic homing missile, or a sound-triggered smart weapon designed to seek and neutralize a noisy camouflaged target.
It's an incredible detail. Ultimately, the city was neutralized, destroyed by a powerful ground-to-air weapon that broke it into pieces and sent them crashing into the sea.
The epic confirms that not only were these aircraft used, but highly complex defensive and offensive countermeasures existed.
And here's where the historical speculation takes a massive, profound turn. We move from high-tech conventional warfare to descriptions of something far more devastating.
Something that parallels the invention of the nuclear bomb.
Exactly. Scholars, even those writing before the invention of the atomic bomb, like the physicist Frederick Soddy in 1909.
He speculated that a former forgotten race of men attain not only to the knowledge we have so recently won, but also to the power that is not yet ours.
He was arguing for the possibility that ancient civilizations might have mastered atomic energy and then perished by misusing it.
And the verses from the Mahabharata that describe the weapon used against the Vrishnis and Andakas, they are the most chilling evidence cited for this.
They describe a single projectile charged with all the power of the universe,
rising as an incandescent column of smoke and flame, as bright as the 1,000 suns.
in that image. A column of smoke and flame as bright as 1,000 suns. That is the defining characteristic of a thermonuclear detonation.
But the description of the aftermath, that's the clinical diagnosis.
It is. The weapon reduced the entire race to ashes, with corpses so thoroughly burned as to be unrecognizable. But the crucial diagnostic detail, the detail that separates this from a massive fire or conventional explosion, is this.
The hair and nails fell out.
That specific symptom, the loss of hair and nails, is characteristic of acute, severe radiation poisoning. It's caused by immense doses of ionizing radiation.
And there's more.
There is. The text mentions that the soldiers, realizing they were contaminated, immediately threw themselves into nearby streams and rivers to wash themselves and their equipment.
Which suggests an understanding that the contaminating agent was transmissible via contact. It required immediate decontamination efforts.
Its entire sequence. It reads less like mythology and more like a detailed, terrified eyewitness account of a nuclear event.
This claim of ancient atomic warfare extends into archaeology, particularly the controversial speculation around the ruined city of Mohenjo-Daro in Pakistan.
Right. This specific claim was popularized by authors like David Davenport and Eric von Daniken. It centers on the city exhibiting signs of extreme, localized heat and devastation,
They cite evidence of black stones.
which analysis shows are fragments of clay vessels that were fused together under immense, localized heat.
Suggesting a sudden thermal shock far beyond what a conventional fire could produce.
And some fringe research has also claimed higher background radiation levels in parts of the city.
Now, before we go any further, we have to note that the source material treats this entire theory as speculative. It classifies the claims as not really authentic, but worth a read.
An important clarification.
But for the sake of completeness, we should explore why the claim is made. The hypothesis states that the city was destroyed not by invasion, but by an instantaneous blast that vitrified structures near the epicenter.
The problem with the Mohenjo-Daro theory is that it lacks the definitive supporting geological or metallurgical evidence you'd need for confirmation of an airburst nuclear event.
Right. While the fusion of the clay is real, it can be attributed to other natural or conventional causes.
But the fact that this specific pattern of devastation feeds into that cultural memory of high-tech annihilation described in the Mahabharata, that's why the theory endures.
The overwhelming devastation that's described in the epics leads logically to a final, profound claim about the suppression of all this knowledge.
You're talking about the legend of Emperor Ashoka.
I am. Ashoka, the famous Indian emperor, supposedly created the secret society of the 9 unknown men.
After witnessing the horrific misuse of ancient scientific knowledge in warfare, perhaps in the devastating Kalinga War,
He realized that this technology was simply too dangerous for mankind.
and so the society's mission was to catalog and preserve these advanced ancient sciences, including the secrets of gravitation or gravity control.
But to ensure that this knowledge remained secret, locked away in 9 books, out of fear that it would be misused again for mass destruction.
It's a legend that represents the ultimate acknowledgement of technology's dual nature: immense power paired with immense responsibility.
And the solution, according to Ashoka, was not to forget the knowledge, but to hide it.
Until humanity was mature enough to handle it responsibly.
So we have completed this extraordinary journey. We've gone from ancient descriptions of thought-controlled Vimanas and highly specific metallurgical recipes like Rajaloha,
To documented NASA experimentation with Mercury ion engines and these chilling accounts of warfare that just echo thermonuclear detonation.
the core contradiction we're left with is philosophically and scientifically challenging.
It is.
Hmm.
Why do these intricate, highly technical details, specifying exactly 272 degrees for an alloy, using mica to reduce heat flux, designing a conical castle for VTL, recognizing the specific symptoms of radiation poisoning?
Why do they appear in texts thousands of years before these very same concepts were independently developed and validated by modern science?
It's the central mystery.
Let's just recap the most memorable technical nuggets we've uncovered. First, the required proficiency of the ancient pilot,
Mastering the 32 secrets.
including using Karshana to magnetically destroy enemies and Langana to prevent the Vimana from catching fire due to the solar glow during high-altitude maneuvers.
And that bizarre, verifiable connection between the ancient mercury-fueled Marutsaka and the concept of Padmarasam fuel.
And NASA's own experimentation with high-density propellants in the CERT-1 mission in 1964.
The ancients recognized the unique density benefits of mercury for propulsion, even if modern safety concerns eventually made them pivot to xenon. It's the same principle.
If we view this technology through the lens of ancient Indian culture, their cyclical view of time where great epochs of creation and destruction repeat eternally, it offers a unique frame.
Our modern view of progress is so linear. We just assume we are always advancing, always getting better.
But the cyclical view suggests that profound knowledge can be achieved, abused, and then completely lost, only to be rediscovered later.
And the deep dive into this forgotten aerospace technology sometimes leads to even more esoteric concepts.
Like those found in translated Tibetan documents.
Right, which describe the anti-gravitational propulsion system not as mere physics, but as something analogous to lagima.
And lagima is traditionally described by Hindu yogis as one of the great siddhis, or powers.
It represents the ability of the human ego to manipulate gravity, allowing a person to become weightless and levitate through mastery of the mind.
Which ties back perfectly to the Kamagam-yanam, the thought-powered aircraft we discussed at the very start.
It's a full circle. If this forgotten anti-gravitational technology existed, was its power purely physical? Did it depend on precise measurements of magnetic fields and mercury density?
Or was the ultimate control system, as suggested by the deepest esoteric texts, tied to a profound mastery of the mind and the manipulation of the human ego?
And that is the question you are left to ponder. Was the ultimate power of flight a mastery of physics, or was it a prerequisite mastery of the self?
And if it was the latter, could BCI technology simply be our modern way of rediscovering an ancient truth about the human mind's ultimate potential to interface with and control the physical world?